Hello, in this talk we'll talk about the software architecture in Windows 10, Windows 10 software management, and compatibility of software in Windows 10. So one of the biggest concepts we need to talk about is kernel mode versus user mode. Here we have a small little illustration. This is actually from Microsoft's web page. The best way to understand Windows 10 software architecture is there's two different modes. We have kernel mode, which we're going to talk about right now, and user mode. Kernel mode is where the core operating system's operations take place. So we have memory manager, thread manager. HAL is, we're going to talk about that in hardware architecture, is the abstraction layer. This is kind of the layer that provides the actual digital interface to the actual real hardware. Okay, whenever we go back and forth between the logical world of the operating system and the physical world of hardware, we're going to have this kind of intermediate logical layer, and that's what the hardware abstraction layer is. All right. Some other things that live in here, we're going to, again, like I said, the memory manager and the thread manager. We have the core operating system. We're going to have things like DLL files, Windows, driver link libraries. These are files that have shared code that's shared throughout the operating system. These DLLs are what operates the this border, for example, right here, ntdll.dll is a DLL that sets up this border wall right here. All right, this is going to be, and then what's going to happen is we're going to have interactions. Like, say if we have an application like Skype, for example, that records video, right? It needs access to the actual web camera, which is down here in hardware. It's going to have to go through an API or some kind of programming program, the applications environment, which we'll talk about. And it's going to access the actual core system. The core system will make the call to the hardware and get the video. But it needs to get that feed to the application. It's going to go through this kind of checkpoint here, okay? And this is done to compartmentalize Windows, right? That way, if we have any problems in the applications world, it will cause a crash in here, and it would be contained in the user mode. It should not spread to the kernel mode. All right. One of the few pieces of third-party software that run in kernel mode, most of it's going to be built into Microsoft. It's going to be core files for Microsoft Windows. But one piece of third-party software that does run in kernel mode is drivers. They're just at the root of the operating system. Okay. The other thing we need to be really careful about is this core, if it gets corrupted by malware, viruses, that type of thing, can be extremely hard to root out, right? So it's very important to try to protect this area. So we have third-party drivers. That's why. So one of the first things I want to mention here is because of the fact that these drivers are running in the kernel mode. Number one, if you have a 64-bit operating system, you have to use 64-bit drivers. 32, you have to use 32. All right, because they're so deep into the system, there's no way to trick. We're going to talk about that in a little bit when we talk about user mode, where we do stuff like this, where we get 32-bit applications to run. We do it all the time. But we can't do that in kernel mode. So the device drivers have to be programmed to handle the processor. So a 64-bit processor has to have 64-bit drivers for all your drivers, not just the motherboard or the processor. One exception to the type of drivers that live on this side are printer drivers. Printer drivers are usually, when it says user mode drivers, it's primarily talking about printer drivers. Those operate in user mode. In general, we're going to keep coming back to this theme, but printers are highly untrustworthy and awful, and so that's why we have user mode, and to put less reliable software out there. So printer drivers tend to be installed in user mode. There was going to be another point I made about the drivers. Also, 64-bit drivers need to be signed with certificates. Again, this is kind of a part of the security principles, because they tend to be in the kernel mode. So they have to be digitally signed with a certificate. And also, if going into the realm of uh, troubleshooting. If I get blue screens of death, which essentially means the operating system just stops, suddenly stops. Seize ups, 100% processor utilization, problems that seem like there's something wrong at the very core of the operating system. One of the first things I tend to blame, other than bad Windows DLLs, which are fairly unique, but they can happen, is I think back to when the last time I upgraded a driver, right? If I've just upgraded a driver, and then all of a sudden I'm getting these freeze-ups, these like sudden freeze-ups or blue screens, I might try to revert back to the previous driver and see if I continue to get those blue screens, right? And part of the reason why is because it is running in kernel mode. You can cause critical failures for the operating system. All right. So the flip side of that is user mode. This is where the user does their thing, right? And again, the user can be unpredictable. The user could be incompetent, and the user could be malicious, right? Or it could be a good user. So we'll try to stay on the sunny side. But a lot of times users can be actually malicious, right? Someone trying to cause harm to the system or install spyware or do something they're not authorized to do, right? So that's why we have user mode, to kind of isolate them a little bit from the core of the operating system. All right, we're going to have APIs out here. APIs are application programmable interfaces. Think about it as like a toolbox or tools, like a button, for example. For folks that have programmed with APIs before, that button comes predefined. Okay, so there's a predefined button that has all kinds of events like on click, off click, mouse over, all these different things that can happen with a button. And obviously much more complex than that. On a third click, double click, there's lots of different things you can do. So that's just with a button, never mind, text or any other of these other features we have in programming, right? So this API provides this toolbox. However, as the end technician that has to work on these machines, we have to understand that the API can cause problems. Or, well, I shouldn't say cause problems, but can be a concern for a technician, right? So if a program we just loaded on requires, let's pick on .NET, right? Needs .NET 6.0 and we only have 5.2, then we're going to have to upgrade to 6.0. However, a seasoned, grizzled veteran of the IT world feels a little hesitant to upgrade to 6.0 because then we'd be afraid of all the other applications we had installed. Is the upgrade to 6.0 going to cause problems? Because think about it. If you upgrade to 6.0, you're changing the definition of that hammer or the button, right? There's new events being added, other events being added. There's slight changes that might be taking place. And also, some program that was written with 5.2 now gets 6. That button definition changed slightly. Hopefully that doesn't cause a problem. Hopefully. It's gotten better. It's not as bad as it used to be, but in the early days of APIs, that would come and be a problem. You would have to upgrade your API in order to make a new piece of software work, and ironically, it would break your older software, which would cause a headache. So be advised of that. Anyway, we also have some application environmental subsystems. Win32, Win64 subsystems, XP and on have used those. They get their own, so it's actually called a Win32 program or Win64, depending if it's 64-bit 32. It runs in its own segmented memory space. Again, this is all kind of about security. We can't can't completely verify what this software, where it's from, or who wrote it, or is it malicious, or what So what we're going to do is we're going to try to segment that. We're going to keep it in its own fenced-in area in the memory, right? To try to keep it from going in and causing problems with the core. So if it's a 64-bit operating system, it runs Windows on Windows 64. So what happens there is if you have a 32-bit program, you can run this thing called Windows on Windows, which is WoW 64. This WoW 64 is like a wrapper. What it will do is it will take that 32-bit chunks of code that come out of the program and try to tie it together into a 64-bit thread. That's an oversimplification, but it'll work. So you have this extra program that's working to interpret the code to get to the processor. All right. Just a point, interesting point that a lot of people don't know is, I haven't booted my operating system. So while that's booting, if you look under your C drive, we'll look at my computer then. Sorry about that. I just clicked on it and expected it to boot right up. If you look at my computer, for example, right, and I'll go into this, I have a C drive. We'll go to this PC, C drive. There it is. Then if you look at programs x86, you can see all my 32. This is all 32-bit code. Okay, nothing too exciting. Sorry, folks. But this is all 32-bit code. Okay, that's our programs that are running in there. As you can see, it's lots of different stuff, reliable stuff. Stuff we're using right now, VMware, right? So these are various iterations I've played with over the semesters. So anyway, that's 32-bit code, while program files is that, and the x86 references the architecture. Program files tend to be the actual 64-bit programs. All right, VMware is in here as well. Some VMware stuff is in here, not the player itself. Anyway, so there you go. I'm going to log in really quickly so we can do the rest of this. All right, that didn't work. Let me just hit Control-Delete. So let's continue on with the talk while this boots up. All right. So 32 bits are installed in program files x86. Again, you can change that. That's just the default. Some other things happen in user mode. We have .NET Framework. Again, .NET is a very powerful API that Microsoft doesn't require, but it would prefer that you use to program programs for Windows. So we also have some other things we talked about. The API programs interact with OS. The Windows Store. So we're going to talk about this in a little bit about installing different software. The Windows Store is perhaps the future, where maybe the only place where Windows can get its applications. Right? One of the reasons why Android and iOS are so secure is, unless you jailbreak, the only place you can really install software is from the store, from the Apple Store or Google Store, or whatever they're calling it nowadays. Obviously, Microsoft sees that and sees a financial gain to it, but also sees a security. They have to vet all the software. That being said, they're still working on that, and again, they're trying to be as open as possible, allowing as many different types of hardware to run their operating system. Windows phones, as of speaking in this talk right now, is close to a dead operating system. Tablets. Our Windows tablets are very much alive and doing well. Windows 10. Desktops is where their business is unassailable. So these applications, right now as it stands in Windows Store, if you go there, you're going to have desktop applications. They're designed to run on the desktop. You have tablet applications, perhaps phone applications, and the apps, for short. In the perfect world, what Microsoft would like to see is universal apps that can run to detect what type of hardware it is a desktop, is a tablet, and install the components necessarily to run properly on that hardware. That would be a universal app. All right. Getting into the world of legacy apps, as many of us know, we have our command prompts, our good old-fashioned command prompt, which we haven't really spent a lot of time in this class because we have PowerShell now, and I do prefer PowerShell. But when I ran command prompt right there, CMD, at the start menu, and brought up my DOS, this is just good old-fashioned DOS, DIR, but I can't do LS because it's not PowerShell. So this is like a DOS simulator, right? No longer does Windows NT. Windows NT never ran on top of DOS. That was Windows 95 and 90X, all the way to Millennial. edition, Millennium edition. So anyway, what we actually do when we run this is run a program called NT VDM, NT Virtual DOS Machine, and it runs kind of this interface with my operating system, so I can run powerful tools, which we will run in this class. Might be using PowerShell instead, but I can run powerful tools like diskpart, where I can actually partition. I have to give it administrative access, but where I can run powerful tools, list disk, no S, list disk, and I can create partitions, volumes, and that kind of thing. So it's a powerful tool that actually touches the operating system, how to get ARM and privileges. I got 2 virtual DOS machines running right now. But it interacts with the operating system, but it's actually kind of a bit of a virtual machine, is the best way they talk about it. Speaking of powerful tools, let's go into the registry. I can run this at PowerShell. It's going to keep doing this, I think, because I'm not full screen. I messed with the resolution. From DOS, well, let me exit out of this. Oops. From DOS, let me do regedit. It's path, so if I type regedit, it'll come up. Again, it's going to complain that I need privilege and privileges. Next, we're going to talk about the registry, the regedit. So we use a tool called regedit here to actually bring it up. It's called the registry editor. You can type it into DOS as regedit, and it'll come up. This is the tool baked into Windows. There are third-party tools, but this gets the job done, and most people end up just using this. There's also another program that we sometimes use. Anyway, let's stick with registry. So talk about the actual registry. All right. So we have 5 high-level keys. All right. So we're going to have keys. We're going to have, let's go back to the presentation. We're going to have keys, subkeys. We're going to talk about Hives in a sec, and values. Okay. So the keys are folders is the best way to look at it. This is like and by the way, the registry goes back, as far as I know, to Windows 1, but certainly Windows 3.1. It's an ancient database. This is where Windows records any changes it wants to remember with the power off. It's a save to the hard drive. It's a giant 2-dimensional flat database that we can store all kinds of information to configure Windows the next time it boots up away from defaults. Okay, so this is like a giant database of settings. Okay, it's quite powerful. It's lost a little bit of power over the recent iterations of Windows. Not as powerful as it once was, but still very powerful. All right. So anyway, we have our keys. These keys are these folders. Okay. Now, if I click on this actual key here, these are the values. Okay, and both these are string values. Okay. This is VXD file, so it's a type of file. Anyway, and it looks like it belongs in the perceived type. It's a system type file. All right. We'll talk about what some of this stuff actually does. Here's .app or appx. Yeah, appx. So appx is a extension, which we're going to talk about a little bit later in this class, which is a application. Something when you get to Windows Store. But like MP3, or where's MP4? But MP3, one we're all very popular with. Anyway, it just tells the program, tells Windows what to open it with. Okay, these are different programs that can open up MP3s. All right, that's all this one up here does. But so we have our keys, our values are inside the actual keys, right? The value is always going to be beside the key. So here's a 0-length binary value. That's fun. And we have strings. We have a number of types. We have binary string. We have what's called a D word, which is just kind of a collection of data. And then we have hex values as well in there. All right. Now the Hives are the top level keys. These are these 5 top level keys. That's why they're called HKeys up here. All right. And the big thing we want to talk about is what tends to be stored. Okay, again, there's always exceptions to most rules, and this is not an exception to that rule. This isn't 100% true, but this is the purpose of these Hives. When Microsoft first came up with this Hive infrastructure, which is, again, we're talking going back to the 80s. This was the overall purpose. It's been glued on to, extensions have been made, mistakes have been made. But this is what they were originally for. So this is the type of software data you tend to find in there. As we just saw when we went through HKey classes root, it tends to have file type definitions. It used to be the only place to do file definitions. Windows 10 does them somewhere else as well. I played with it a little bit. You're supposed to use DISM to modify, create an XML and modify. Anyway, this is where and a lot of classes are. So let me go actually to give it a quick example. We'll go to a popular one, .txt. And if I click on here, if I do shell new, it'll tell it that if I double click on a TXT, I should open it up in Notepad, and the size of the window should be 470. If you ever noticed, if you played with Notepad, last time you successfully closed it out, if you made it really tiny, next time you come up, it comes up tiny, right? That's something that you would save into the registry editor, right? It's actually saved to the hard drive. That way, if you reboot your machine, that setting won't be gone forever, all right? Anyway, so that's the type of stuff that's kept in HKey classes root. It's a file definition, right? HKey current user has, this is what makes our operating system customized, right? We're playing with the start bar, or previously what's on my taskbar. A lot of that stuff's going to be recorded in here in the registry. And when the change is made, it's actually changed in the registry. All right. Now, a good chunk of this current user is going to be loaded up from a file that's in your profile, which we'll talk about later in this course, user profile called the nt.dat. There you go. That's File Explorer. Last time I closed it, had a weird look to it, or was stacked or something. But if we go into users like CIT120 admin, ntuser.dat, there you go. So a lot of these things get saved or loaded up from ntfile.dat. Some will get loaded from HKey users, which we'll talk about. But these are all settings for my current user. This is what makes Windows, gives it the look and feel. So like what desktop I'm using is we're going to be recorded here. How I like certain things on the control panel, and it will be saved in here, that kind of stuff. All right. So that's HKey current user. HKey local machine are global settings. Here are my boot settings right here. That's the purpose of local machine, global settings for the entire machine and applications. So if you have an application that affects all users, it might save in HKey local. This is where it's going to get a little wishy-washy. It'd be nice if there's just one place where applications would store their stuff. But through the various iterations and backwards compatibility issues, it's saved in multiple locations. So we have HKey local machine has global settings. We have HKey users, where it has some user-specific settings stored. It's going to be stored under their SID, which we haven't talked about. Here's the SAM, actually. SID is kind of an identifier. We'll talk about this later when we talk about security and authentication in Windows. But it's saved under the actual SID of the user. Okay, and again, some of these are settings that get loaded up to current user. All right, and then we have HKey current config, which is kind of the best way to understand it is the current configuration of hardware primarily. There is some software kept there. Usually, when applications save things, they tend to save things in HKey local machine. They can save things in current user, especially if it's user specific. And that's kind of part of the problem. As Windows went through, one of the problems we had with Windows security was the registry was wide open. You could write to any part of the registry. And again, malicious software, bad intent, and, well, disaster. So what Microsoft started doing is particularly we gave it like NTFS-like permissions. Okay, let's go to the current user and look at something like printers. All right. If I right click on that and I go to permissions, we actually have permissions just like opens a file. We'll talk. It has an access control list, as we call it, on everything. And so it started locking down registry keys. Certain registry keys you just can't write to. Registry keys you weren't supposed to write to. So here we go with software, fonts. It's a D word. There you go. So if an application tried to write to a part, it would get blocked out. That was and this was around the time of Vista, and that was one of the problems Vista had was programs would just crash out. One of the reasons why they would just crash out is they tried to write to part of the registry, couldn't do it, and the error wasn't handled, and it just died. The program died. So what Microsoft has done is they can create virtual keys and virtual values that it will allow software to write to the registry. It's really just faking it, and it's actually just kind of writing to a separate part, and Microsoft redirects it. It's a switcheroo. All right, so that happens. It's not a massive part I want, that you need to concentrate on. I'm just letting you know one of the problems they had. So there you go. There's the registry in a nutshell. We don't spend as much time in the registry as we used to trying to fix Windows, but it will pop up from time to time, so it does help to know it. Okay, so again, it's a big database of stuff we want to record, of especially changes that we want to have next time we reboot. A lot of those software changes are going to be kept in the registry, and like hardware, actually not, it's just the information about the hardware, obviously, right? All right, so let's talk about ways we install software in Windows. We have the new, the new mainline, that's a good way of putting it. Standard for installing applications in Windows is .msis, Microsoft Installer Service. It's a file built for Windows Installer Service. Best way to look at it is like a manifesto or a checklist or a set of instructions. Okay. And then I'll copy files in places, make changes to the registry, that type of thing. All right. So really, it's just kind of an instruction set. All right. Win32, Win64 uses it. .NET Framework programs will use it. We can automate it. If we call that execute, we can call Windows Installer Service in the background and point it to the MSI. We can run it with a batch file or a script or something, which is powerful for administration. Use the /Q switch or the quiet /quiet switch. If you need answers like region codes, that kind of thing, whatever software might need, file locations, installation locations, that kind of stuff, keyboard settings, anything like that. If you need answers needed, you can create a .mst file that provides answers. You just got to point it when you execute Windows installer. It's not elegant or robust, actually. It's a little bit tricky to work with, but it is the primary way we install programs in Windows nowadays. Not the only way, but Microsoft would prefer to run Windows Store apps. It can use the appx or the app file to sideload an application. So when we're talking about sideloading, is a way to kind of install it if you don't have access to the Windows Store. So again, if you go to the Windows Store and you install an app, it's going to have this pre-packaged file in a .app or nowadays .appx. My word of advice in Microsoft land, Microsoft's been putting a lot of their manifests in XML format, and if it's has an X at the end of it, it means it's an XML format. Think of doc, right? .doc, DOC, Delta Oscar Charlie. And there's docx, right? So the new word uses docx. If you look at it, actually, and open it up as an XML document, a lot of that stuff is tagged in XML. Anyway, that's why there's an app and appx, and the newer format is appx. Anyway, it uses that appx to sideload an application, a local source. Microsoft can create. When I talk about sideloading, what you can do is you can get your actually hands on the appx or the .app file. You can actually load up the application, not through the store, but through another media, USB drive or something like that. All right. Microsoft can create a specific storefront for larger businesses. So if you have a large business and you talk to Microsoft, they can set up a storefront. That way it gives your users a illusion of control. So again, Microsoft would like to see more Windows Store applications. Also in the future we have package management like Linux for folks who've used Linux before or using Linux now. If you got Debian, you got apt-get, Red Hat has Yum. Those are all package management, and what package management does is you have a central repository with the actual software, but also dependency trees to know what software it needs in order to run, right? Software can be this kind of interweaving collection that needs one type of software to run, not only what you're downloading, but a couple other pieces of software, system software that needs to be installed. So again, Microsoft would like to do that. Again, at the package, at the command line. This is a command line interface. So it would download it from a central repository. It's just starting off now. It's new technology, but they call it package management. And there's good old-fashioned EXEs, old school, not stable. You need to be an admin a lot of times, almost every time. A lot of software still uses it, much to the chagrin of Microsoft. I mean, they would like to get away from it. There could be lots of compatibility issues. This is kind of wild, wild west, right? This is Microsoft has very little control of what these EXEs are going to be doing, especially if we're running them as administrators, and they can kind of go anywhere they want on the hard drive and touch anything, kind of anything they want on the registry. So Microsoft would prefer to stay away. The uninstalling. When you uninstall software, what it actually does, the software actually does, is it kind of has a manifest that's created during the install process of what to take out if you want to uninstall it. And so when you actually bring up your Windows, add remove program, right? So we're going to add or remove programs. When you bring this actually up, what happened is when the software was installed, it created this kind of cookie crumb on how to uninstall it. Not all the time do applications give a full cookie crumb. They might be leaving stuff behind. Most of the time they're pretty good about not having services or stuff like that run in the background. But that's something to be aware of. If you have a good old-fashioned EXE and it's just kind of a haberdashery, not really, it won't create a cookie crumb trail, right? It won't even show up in the add remove programs because Microsoft doesn't know about it, right? It doesn't register itself with Windows. So just again, something to keep out. If it's MSI, it will. It's part of the process of creating an MSI. Windows stores apps and package management. Well, package management, I think you'd have to do it through the CLI, but again, that's kind of cutting edge. It's not fully formed on what it's going to do. So, all right. So let's talk about application compatibility. Primarily, our concern is older apps running on Windows. So a couple things we might have to do is, again, we have this problem where apps were playing by old rules. I'm going to do this on my own machine because I don't have a lot of EXEs that weren't installed by Microsoft. Actually, I know one on my virtual machine that was, because we have the VMware. We have the VMware tools, which I think is in x86. So you'll find out with me at the same time. Program files x86. No VMware tools. Program data. VMware. I guess it's 64-bit. So we have VMware tools right here. So I should have. I'm looking for an exe, some kind of executable. That would make my life a little bit easier. So that's where I would expect to see an exe. Oh, there's my problem. I'm in program data. My fault. Program files. Learning moment there. VMware tools. Let's see. There's an exe right here. Okay. So those are the DLLs. All right. Again, DLLs are shared code between multiple machines, right? All right. Let's just grab one of these. That's a setup, but here's the daemon running. Okay. So if I go to properties of this, all this, so I didn't have to do anything, and I have a compatibility tab. All right. When I run this program, every time this program is run, I can tell it to run using certain rules. Pretend it's Vista, pretend it's Windows 7, pretend it's 8, right? These are all different rules I can play. Older ones actually had Windows 95, Windows 7 had Windows 95 and stuff like that. But, so anyway, I could try to kind of fake it and pretend it's an older version of Windows. Some programs I can reduce the color mode to help compatibility, make it visually, disable full screen optimizations, that type of thing. All right. So that's what we're talking about when we're talking about compatibility. This is a big deal. Compatibility is a huge deal, right? For a lot or large organizations, compatibility is what stops us from being able to upgrade to the latest operating system, right? It might not be a budget thing. If I upgrade to the latest operating system, my programs might not work, and that's obviously a huge problem. So getting compatibility to work is a major concern. All right. Again, registry and hard drive access can be a problem, something you have to worry about. APIs, we talked about, different versions of APIs. That's what just showed you, setting capability, setting in exe properties. And then we can also tell it with that compatibility as well, which I forgot to show, that we can have it when we run this to run it as an administrator, run this program as an administrator. All right. So whenever that program runs, it's going to need administrative access. We're kind of notifying the operating system of that. All right. So those are the things we could do as a quick little fix to fix compatibility issues. If we have a long-term compatibility issues, there is a toolkit, application compatibility toolkit. It's part of the ADK, the Assessment and Deployment Kit for Windows 10. Again, this is a big deal for companies. There's companies who struggle years and years and years to get all their workstations up to 10. A lot of workstations, you just upgrade to 10, don't have to worry about it. But if there's customized software or software from a vendor that's a small vendor, or there can be all kinds of stumbling blocks, right? So there's various tools in here that can be used as part of the ADK. Logs, databases of known issues, that type of thing. Okay. So what can we also do if we have compatibility issues? Well, these are less popular options, but and rather extreme, but sometimes necessary. So sometimes we could actually have Windows run what's called so hypervisor is Microsoft's Visor software that can run the old operating system, so you can run the old operating system within your operating, run a virtual machine, and then run the app. So then the user would have to double-click Hyper-V, spin up the operating system, go into the new operating system, and run the application. Users are not big fans of this. Obviously, it's extra steps. Plus, it's a bit confusing if you're one operating system, not the other. If there's external files, you need to move the files around. Users are not in love with this solution. But if it's all you got, it's all you got. We also have virtual desktop infrastructure. So what we could do is run a virtual desktop on a server, and then you just get the video feed coming in over the network, and then you can execute the app on that. Instead of actually running it on the local machine, you're running it on a server and just getting that sent over. You can also use remote desktop to connect to the app running on a remote desktop. So you just run it on an actual physical computer and just remote desktop in. Again, all these are not very favorable. There's no perfect solution here for the user. The user's not happy. They're taking extra steps. AppV is another solution. You need the infrastructure for it. It's rather expensive. You have to plan it out. But if this is a serious problem for your company, it might be worth the time, money investments. Okay. So application virtualization runs on a remote machine, is streamed to the desktop, seamless to the end user. You need the infrastructure to run it. So there's my presentation, and I'll talk to you later.